When you create a new project, it is important to think about how you want to structure that project. That's why in this video I want to take you along to see how I like to structure my project into different files, and also some tips and tricks along the way. I'm going to take you through 3 different steps to enhance the overall structure. Now all these steps have a little bit of pros and cons, so you have to figure out what you want to use. And then also I want to mention that of course this is just one example of how we can do it. There are plenty of other ways. And this might be a little bit more verbose than you're used to. And that's because when I create my project, I like to think that I want to be able to maintain them in the long run. Of course, if you just want to create a quick demo or something like that, there's nothing wrong with just creating everything in one file, getting up and running, and you're good to go. But if you want to create a project that's going to be long-lived and that you want to keep maintaining for a long while, maybe you have multiple team members all contributing to the same code base, it is important to define a set of like structures so that everyone is on the same page and understands what is going on. So with that said, let's take a look at my file structure first. So what I have in front of me is a basic TanStack application. Now of course the concept that I'm going to show you in this video could be applied to other frameworks as well. If you go into the source, we have some TanStack specific files. We don't really care about them in this video. We have this components folder. This is where I would define my global components. So I have some error components up here, and then this project uses shadcn. That doesn't really matter. What matters is that inside here we have like buttons, input labels, you could have dialogues, whatever, components that you want to use throughout your whole application. So that's why I call this a global component. Then we have this features folder. I'm going to go a little bit in depth in that later. Below that we have this lib folder. This is where I would integrate with third-party libraries. So that's why I've had this utils file, which is a Tailwind merge file. Then I have this db folder. This is where I define my Drizzle configuration. So I create my Drizzle client. I also define my schema. Now, the schema isn't actually defined right here. The schema is defined in each individual feature. I just import them here in this like global area so that I can use them in the client. And then we're going to take a look at the feature later. Then we have this routes, which is just a file-based router that comes default with TanStack. We have some styles, which is just some Tailwind styles, but you could have other global styles here if you want. And then we have utils, which is also global utils that we might want to use throughout our application. So essentially everything that we have directly in the source are global things that we want to use multiple places in our application. Then I like to split my application into different features. And that's where we get into this feature folder. Right now this is just a really basic example app with a to-do. So I have a auth feature and I have a to-do feature. Now a feature could be basically whatever you want. But the idea is that we want to have all the code all in one place for a single feature. So if you're working on a new feature, if you want to change how a feature works, then you should only be concerned about whatever files are in those features. This auth feature is just, I haven't really done much here. This is just to show you how it can be done. But then we go into this to do, and here we have a lot of different files. We have the schema. This is where I define the to do table that I imported in this global database schema. Then we have types. These are application specific types that I want to use in this to do feature. I'm just inferring it based on the Drizzle schema. That doesn't really matter. You can define your types however you want. Then we have some validations. I have here a add to do validation that I'm going to use later. And then, because TanStack is a full stack application, I like to separate what is client-side code and what is server-side code. Now, if you use, for example, a React with Vite, you only have client-side code, so you don't really need this. But it could be still a nice idea to have a feature table and just have this client folder, for example. Inside my client, I used to define my actions because I like to use TanStack query. This is where I will define all my like use queries, my use mutations, my query options, and all that stuff. Then I have this components folder. I have to-do form, to-do item, to-do list. So this is where I would like to define my feature-specific components that I'm only going to be using in this feature. Then if we jump over to the server, this is where I would define my server-side logic. So I would usually have these three files: a controller, a service, and a repository, or repo for short. The controller is basically where I would like to define my endpoints. So endpoints for like getting to-dos, adding to-dos, updating to-dos, all that stuff. Because I'm using task like start, I use this with the create server function. So we have this get to do and add to do. And then this is where I would do validation. So I use the add to do validation. I could also add middleware here for authentication and that stuff. But the core business logic is going to happen in the service.ts. So that's why when I'm done with the validation, I'm done with the authentication and all that stuff in the controller, I call my add new to do from my service. This is where I would define all my server or business logic. Now in this really basic example, I don't really have a lot of business logic. I'm just calling find all to-dos and save to-dos from my repository. But if you had a more complex app, you would have more complex business logic, and this is where you would define that. Then you go into your repositories. This is where you would connect to your database or do queries to your database. So I am importing my Drizzle database client, and then I'm querying for to-dos, or I'm inserting to-dos. But this isn't really logic. This is just querying the database. So this is the general structure I like to have when it comes to my files. Now I like to take this a little bit further. For example, right now, as you can see, every single function is exported, and that's same for the repository. It's done like that for the service and also for the controller. Now, if you have noticed, you can see that the naming of them has to be a little bit different. So I have to do get to-dos, get all to-dos, and then inside the service I have this get all to-dos, and then that's calling find all to-dos. So I have to do a little bit of trickery with the naming of the functions, because obviously I can't name them the same. So a way to get around this is, instead of exporting the function like this, I like to create a object called to-do service, and inside here I add all the functions. So get to-dos and add to do. Then I can rename these functions to add to do and get to do's. And then instead of exporting these functions, I can export this object which has a reference to these functions. Then inside the controller, instead of importing each individual functions, I can call the to do service and import that, and then I can call get to do's, and I can also do the same down here. To do service add to do. Now the good thing about this is also that I don't have to remember all the different functions. I just need to remember that, okay, in this case I want to call the service. So then you can call to do service, and then you get type safety and completion on what the functions you have available for you. The way I like to name these constants, it's with the feature name, which is in this case is the to do, and then whatever type it is. Is this a service? Is this a controller? Is this a repository? So we did this to the service. We can also do the same to the controller and the same to the repo. So now it's much more obvious what I'm doing. I'm calling the to do service get to do's, and then inside the service I'm calling the to do repo dot find to do's, and this becomes a lot easier to work with. Now, of course, in this example, having this service layer seems a little bit redundant, because all I'm essentially doing is just calling the repository. But keep in mind, this is just a really basic example. Normally in your application you would have a lot more business logic. For example, in this add to do, instead of just saving the to do straight up, we can maybe do some checks here to see if a to-do of a similar title is already created. Maybe you don't want to allow for that. If you do, maybe you want to send like a message to the user saying, hey, this to-do is already created, maybe create a new one, something like that. And that is the purpose of this service file. Now, this approach usually works really well. This has a little bit more boilerplate, because you have to create these constants, but it's not that much. And the autocomplete and the stuff that you get from it makes this almost always worth doing. Now, sometimes I like to take it even a bit further. However, to take it to the next step, we kind of have to add a lot more a boilerplate. So I'm going to show you what the next step would look like. Okay, so here we have the new structure. The main thing you can see here is that instead of just having one single file for controller, service, and repo, I have created a folder for the repositories and a folder for the service. And this is because now we have multiple files here. The most important file or the most important changes is the interfaces. So I have created a repository interface which just define all different methods that the repository should implement. And I have done the same for the service, a to-do service interface which defines all the methods the service will implement. Then I have this repo.ts file which exports a class, a to-do repo, that implements that interface that I just mentioned. And then this class also implements a singleton. A singleton is a concept that we can use to create a single instance of a class, so that if the instance already exists, we just use that. If not, then we create a new one. That's not that important. The most important part is just that we implement the method down here that is defined in this interface that we have defined here. And then I have done the same for the service. Now the service, of course, uses the repository. So we say that in the constructor we want to take in the repository as an object, so that we can later down here call the repository.find to-dos. And the good thing with this is that now we have something that is called dependency injection. So I have also created a service factory. You don't really need this. There are other ways to get your service created based on the class. But a factory is one way to do it. This service factory basically has one function, and that function is to create a service or get a service. What it does is that it creates a repository by calling the to-do repository.getInstance. This is from the to-do class. And then we do the same with the service getInstance, but then we pass in this repository. This way we can go into this controller, we can get our to-do service is our to-do service factory.getInstance, and then we can use the to-do service down here. Now, for now, this seems like a really, we have the same functionality that we just did, but there is a lot more boilerplate. So why do we want to do this? Well, one example is that if we want to test this without actually connecting to our database, we can now go in here, we can create a repo.mock, for example, that I like to call it, and create a class to-do repo mock, make it implement the to-do repo interface, and then implement the functions. So I'm just going to do that real quick. So here I have defined a really basic mock. We just have the same function that the interface says that we have to implement, the find to-dos and the save to-dos. We just do some mocking of it here. We don't actually call it the database or anything. And then inside the service factory, what we could do is we can have like a flag, for example, in our environment file up here. We can create like enable mock. We can set this to true or false. So let's set it true to now. Then inside our factory, we could get the enable mock. Then if enable mock, we could let's just create a repo object up here, which is going to be to repo. If this is the case, we create a new to do repo mock. Otherwise, we call the get instance, just like that. And then we pass whatever repo that we created into this to-do service. So now, when we set this to true in our environment variables, we could create a mock of the repository instead of the actual implementation that actually connects to the database. And then we can pass it into service. So whenever this to-do service calls the repo.find, we don't really care how the repository does it, we just know that it should do it. And this could be really good for testing. If you just want to test without connecting to a database, you could just enable the mocking, and then there you go. Another thing is that we could much easier unit test this. And as I said, this service file is where we want to implement most of our business logic. So this is something that we really want to test, right? So we do want to implement unit tests for these functions that we have here. So with this structure that I have right now, we can pretty easily do that. I have created this server.test file. Inside here, we have a simple test that checks if we can create a to-do. What we are doing here, we're just creating a mock, which is this to-do mock that we have defined up here. Now we don't have to use this class. You can create a mock directly in here. And then we pass that, we create a new instance of that to-do service with this mock. And then we call this add to-do, and then we check if we get 2 back because our mocks that we should get back 2. But then we can also add another test here that maybe if a to-do with the same title is already created, then maybe it should throw an error. Then we can check that. and all that stuff. So this video is just to give you an idea of how you can structure your code base. You don't have to do it exactly like I have here. As I mentioned, you could start with the first one and maybe you could go to the second one if you feel like that's better. And then if you really want to take it to the next level, you can go to the third step with the interface and all that stuff. Now for a lot of people, this might be a bit overkill, but in the long run, this could really benefit you. So it depends what you want to do. And as I said, this is just how I like to structure my code base. If you want to quickly spin up a demo or something like that, this is overkill and you can just code everything in a single file. But if you want to have a long running project, then you might want to look into the structure a little bit more. And of course, if you don't like this, you can always find other approaches as well. So with that, thank you for watching. If you have any feedback, please leave a comment and I will see you all in the next one.